Good day, great nouns. We have looked at all of the theory with regards to other shapes as in up to quadrilaterals at this point. So now we look at polygons. And remember, you were taught that a polygon is a closed plane figure whose boundary is formed by 3 or more straight lines. So it's a closed shape where all the edges basically meet at a vertex. There's no openings. Then a regular polygon has all its sides the same length and all its angles the same size. Okay, like in a hexagon, regular hexagon, where all 6 sides are the same length. Okay, a convex polygon, just a specific note with regards to this, as we are going to mention it further on in the notes, is when all the vertices point outward, versus concave, you've heard of that before, polygon, would be when there's one angle at least that is facing inward, that is like squished in. So first note, in a polygon within sides, this is some new information over here that you have to learn and maybe make a note of in your book. So make sure all the time when we send these that you make the notes in your books as well. Okay, so let's carry on with this. So there are sides in this polygon that we're talking about, meaning any amount of sides for any polygon. This relates to that. The sum of the interior angles can be calculated with the following, either of the following two formulae basically. So we've worked with the sum of the interior angles of a triangle so far, which we know is 180 degrees, and then also the sum of the interior angles of a quadrilateral, which we know is 360 degrees. So now we look at the ones which have more sides and how to find the sum of their interior angles respectively each. So you can just use this formula for anyone, even a triangle, which we know though, as well as a quadrilateral. It works for all of them. So you just substitute n, as in n is the amount of sides in that specific polygon mentioned. Okay, so let's look at an example together. Just by the way, this says 2n minus 4 right angles. So I'm just going to show over here what it basically means. It's 2 times the number of sides minus 4 in the brackets, and then right angles, meaning that it's times 90 degrees. Okay, that's another way to write it. Or the other formula we can use would be the one that says 180 times n minus 2 degrees. That's how we get the amount of degrees. Okay, so let's look at an example together. In this example, if a polygon has 5 sides, then A, from the formulae that's given to us, the sum of the interior angles will be, and then we substitute 5 in the place of n. So 2 times 5 minus 4. 5 minus 4, there needs to be brackets there. And then that would be multiplied by 90 degrees. Okay. Let's just put this in our block brackets since we have brackets there as well. And that means it's 10 minus 4 times 90, and that gives you 6 times 90, which is equal to 540 degrees. Okay, then the sum of the interior angles in the other method would be calculated as 180 times n, the number of sides, which is 5 sides, as mentioned here. I mentioned it there. Okay, so as mentioned, 5 minus 2 then, that's the amount of degrees we get. And then that, when we calculate it, is 180 times 3, and then it gives you 540 degrees as well. So regardless of what formula between these two you use, you get to the same answer. But sometimes it's useful to work with the amount of to work with this formula when the amount of right angles are actually given, as you're going to see in one of our later questions. So, or if you want to see it, if you're more of a visual learner, the sum of the interior angles can be made up of 3 triangles. And we know the sum of the interior angles of a triangle is 180 degrees. So it's angle 1, 2, and 9 here all form 180 degrees plus another 180 degrees by 3, 7, and 8. And angle 4, 5, and 6 form another 180 degrees. So all together, it's 180 times 3. Does it make sense? So it's just with regards to how many triangles you can form from vertex to vertex polygon. Okay, so now for note 2. If the sides of a convex polygon are produced in order, then the sum of the exterior angles so formed would be equal to 4 right angles, in other words 360 degrees. So the sum of the exterior angles for any convex polygon, remember convex polygon, all the angles are pointing outward. Okay, so here we've got that angle. See, these are polygon. Okay, and all the angles are pointing outward. There's no angle being dented in, if I can put it in that way. So all of these together, that angle being formed by a line being produced to the outside every time, that would be equal to 360 degrees altogether. Okay, so here they're telling you those angles altogether is 360 degrees. Your reason, because remember you're still going to have statement and reason, your reason would be the exterior angles of a convex polygon. And then a regular polygon has all sides equal and all angles equal. So here's a regular hexagon example. Okay, now let's look at an example over here. They tell you solve for x, and we count how many sides. This is not a regular polygon, but that really doesn't matter. We count how many sides and angles it has, and then we count 5 altogether. So these are just sizes of the angles given in terms of x. 3 times a certain size, 3 times a certain size, 4 times a certain size, etc. what's given. So the sum of the interior angles is 2n minus 4 right angles, they're saying specifically, yeah. Okay, now, so the sum of the interior angles, we kind of know the sizes of the angles in terms of x, don't we? So we can put it that way. We can say that 2x plus 4x plus 3x plus 3x plus 4x is equal to 2n minus 4 times 90 degrees. Now, just a quick stop over here. N, we know is 5. So we can say 2 times 5 minus 4. And let's just make these block brackets, since we already have brackets inserted in there. So now the natural reaction should be that we add all these like terms together. 2x, 4x, 3x, 3x, 4x. And that gives you 16x, if you add all of them together, equal to 10 minus 4 this time, again 6 times 90, and we know then that it gives you 540 degrees. So 16x is equal to 540, and this knowledge now helps us to solve for x by dividing by 16 on each side, and that is equal to, if you put it into your calculator, 33.75 degrees. Okay, so before you move on to exercise L, I'm going to add in another page and just do another example with you guys. I feel that that's really necessary. So in this example, we are asked a few questions about the polygon next to this, and it says name the regular polygon alongside, and if you count all the sides, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. 10-sided polygon has a certain name. Decagon. A decagon is a 10-sided polygon. Okay. So this is specifically a regular decagon. Calculate the sum of its interior angles. Remember, my preferred way, by the way, is to use 180 times n minus 2. So sum of interior angles equals 180 times n minus 2, which is n in this case 10, because it's 10 sides, minus 2. And that gives you 180 degrees times 8. And if I put that all into my calculator, it gives me 1,440 degrees is the sum of the interior angles of a decagon. So any decagon has 1,440 degrees as the sum of its interior angles. Now for question C, calculate the size of each interior angle. So if you think logically about it, you would just divide your sum of all the interior angles together, and that you divide by the number of angles there are, because remember, this is a regular polygon and all the angles are the same size each, so you can divide it evenly. So that therefore you can say the size of each interior angle equals the 1,440 degrees for all the angles together divided by 10. It's the amount of angles there are. And that, of course, gives you 144 degrees for the sides of each angle. This could only be done if we know that it's a regular polygon. Okay? And then D, calculate the size of X, an exterior angle. So remember, we know that the sum of the exterior angles all together would be 360 degrees. No matter how many sides and angles it has, those angles produced in order. So when there's a line produced here, that angle, and then from this side next to it, if there's a line produced there, that angle, and then that angle from the line produced there. So that means the size of each exterior angle would be obtained by dividing the sum of all of them, which is 360, by the number of angles once again. So it's kind of the same of each exterior angle. So each exterior angle, and that would be 360 divided by 10 again, and it gives you 36 degrees. And that's it. So I hope this gives you a bit more comfort to working with the formulae and thinking logically about manipulating them to calculate other things. So just have a look at the worksheet. It's got about it logically, please.